lab in A-Star. My specialty is microfabricating devices that are made of biocompatible materials, and these devices are used as drug delivery devices, and we can make intricate designs that feature gears, and some of them look like the Geneva Drive device that is commonly used in Swiss watchmaking. We had this technology where we could microfabricate hydrogels and make them into micro machines. And an obvious application for this technology was to make drug delivery devices. Basically because the material is very safe for use in humans and has been FDA approved, we decided that it would be cool to use it as implantable drug delivery devices. So one of the applications that we actually looked into was to deliver low-dose chemotherapy locally to a tumor. So I came from a lab that traditionally did a lot of microfabrication work. So things like microchips and things you normally see in electronics. But we were gradually branching out into working with materials that were safe for the human body. So there was a need for devices that were safe to be implanted in the human body and that you can control after implantation. So we incorporated a lot of these traditional silicon-based technologies into making devices that were safe to be used in humans. I think it's good to be open to different ideas. So my training was in biomedical engineering. So the name itself indicates that you have to be rather interdisciplinary. So I work with a lot of people in different fields. So I have to talk to materials engineers, clinicians, and have various collaborators. And oftentimes you have to be very receptive of ideas from other people and see how you can incorporate it into your own work.